What's up, awesome people? Welcome to my YouTube channel. This is my very first video. I created this channel literally a few minutes ago to share my knowledge with awesome people like you. So, subscribe to my channel. I will regularly post videos that will be useful for people like you. So, in this video, I want to teach you about an important concept that will help you if you are going for software engineer interviews, regardless of which language it is, Java, Python, C++, what have you. So we're going to learn about big O notation. Let's jump right in. So first thing I want to talk about is about algorithms. So what's an algorithm? It is a procedure for solving a problem. As simple as that. It is a procedure for solving a problem. As we all know, we can have multiple solutions for a problem, multiple multiple algorithms for a problem. So each algorithm could be different in terms of performance. So how do we analyze algorithms? How do you compare one algorithm with another, and how do you do it in a proper way? That's what we're going to look at. So look at a couple of you can look at algorithms in a couple of different ways. So you can look at how much space an algorithm is taking in the memory. That is the amount of memory space taken by this algorithm that you're comparing in memory, right? So on the other hand, we have time complexity. So time complexity is basically looking at the runtime of an algorithm, and not just runtime. We're interested in how the runtime of this algorithm changes, how it increases as we increase the input size, or as the input size grows. So when you're looking at the amount of memory space taken by the algorithm, it is called space complexity. When you're looking at runtime, varying runtime over input size, that's time complexity. So, and that's where big O notation comes in the picture. So you can the the best way to look at an algorithm and its performance is by looking at the number of variable assignments happening in the algorithm. In order to understand this better, I have a simple example for you guys. Here we have two different solutions for a problem. The problem here is we need to we need to come up with a solution to find the sum of a sequence. Like in this case, our sequence is 1, 2, 3, 4, 5, and the programs are written in Python language. So the first solution that we have here is a straightforward one. All we're doing is we're assigning 0 to a variable called sum, and we have a for loop that iterates over the sequence list, and then with each iteration we are just adding the value to the sum variable itself. So once we are done with iterating over this list, we would have the sum of the sequence. So when you run this, you get 15, which is the total of the sequence. So if you look at the number of assignments, variable assignments in this first solution, we have one assignment right here, and we have 5 assignments, variable assignments happening here in this loop. So for an input size of 5, like this sequence has 5 values in the list, we have 6 assignments. So in other words, so the size of input is 5 and the number of assignments happening is 6. When the number of input size, or the input size is n, number of variable assignments is n plus 1. So this is basically the big O notation that we've been talking about. So the big O notation for this algorithm is big O n plus 1. And we're also going to look at something called asymptotic analysis. What it basically means is when the input size tends to infinity, or when the input size is really large, then we can start ignoring certain terms in the big O notation. So this can be simplified to big O of n. So yes, so big O of n is the big O notation of this algorithm. Let's look at another solution for the same problem. Here the problem is again the same thing. We need to find the sum of the sequence, but instead of iterating over each value in the sequence, we just use this formula. So if you can recollect this formula from your high school, it is, if you want to find the sum of a sequence, given that there are n numbers in the sequence, the formula is n times n plus 1 by 2. So instead of iterating over a list, we just use this formula to calculate the sum. So here, if you look at the input size again, it is the same. We have 5 values in the sequence, but number of assignments happening is just 1. And when you have n values in the sequence, the number of variable assignments is still going to be 1. Hence, the performance of this algorithm is going to stay constant over a varying input size. So in other words, the big O notation of this algorithm is big O of 1, meaning the performance of this algorithm does not change. So a few important things to remember about big O notation is, with big O notation, we are only concerned about runtime growth over the varying input size. We're not really looking at the runtime of the algorithm itself, although most of the times in the real world we just run a program and look at how long it runs and then compare it with another program, or just look at the elapsed time of the programs. So here we're looking at the runtime growth over as the input size grows. And when the input size is really large, we start neglecting certain terms and big O notation. And that is called asymptotic analysis. And here are the various big O notations you can have for algorithms. We just looked at big O of 1 and big O of n, which are constant and linear. We also have logarithmic, we have a log linear, we have quadratic, cubic, and exponential. So when you walk into an interview, if the interviewer is asking you to find big O notation of a program, don't be surprised. All he wants you to do is analyze the program, analyze the pseudocode in front of you, and come up with the big O notation. And you can simply do that by looking at the number of assignments happening or number of steps being taken. So that is what is big O notation.